So let's start. Hi everyone, thank you to be there today for a new session with Mike Wojtyna. So we will talk today about domain experiments. Mike was there, I think, 1 month ago during the meetup with Valentina on clean architecture. It was really interesting, the discussion we had during this session. By the way, it's online if you want to review it. And Mike proposed to make a session, an interactive session on domain experiments. So basically, we'll see example mapping, test-driven development, domain-driven design all together. So I think it will be really interesting. Don't hesitate to ask questions. We have some issue with or some surprise with Zoom today. So don't hesitate to ask your question directly on the chat, and I will ask the question directly to Mike if necessary. So Mike, floor is yours.
Thank you very much, Ian. Okay, hi everyone. We are having some technical issues, so that's why I'm sharing my screen with camera turned on the screen. So let's just say it's a kind of experiment, okay? So yeah, I'm going to hide the window now so I can focus on the presentation. But at least, well, I can say welcome. Okay, and let's close it now and let's focus on the presentation then. Okay, great. So we are going to talk about something I call domain experiments. I'll show you some examples later, but before, let's start with a story of some project. This project is called a crowdsourcery. It's a crowdfunding platform supporting passive investing. So lazy investors don't need to pick manually their investments. They can just invest into groups of assets. So it's a fictional project, but based on some of my experience. Okay, so behind the project, there was a really, really great team of experienced developers, experienced superheroes, as they usually call them. We had awesome product idea. It seems really nice and useful. And the team was also focused on code quality and good design. Following all the best clean architecture principles combined with test-driven development, domain-driven design, and also used and applied best infrastructural practices like GitOps, for example, where we manage all of the configurations on our Git through Git configurations. Okay, so it seems the result should be fabulous, right? We have everything we need to make an extraordinary product developed by best developers out there. So the result was a total failure. It didn't even go out on production. The project was simply a toy project created to demo some things, and it was never really used. So why did it happen, right? What do you think? What was the main reason behind the failure? I'll try to open the chat now. I don't know. Oh my. Yeah. Okay. So maybe let's continue and then we will have a discussions. Business side lack of vision. Yeah, something similar to this. But there was one main reason behind the failure. And basically, we can say the failure is that we don't know what we need up front. That's normal. But the team failed to understand that building software and designing the right model is all about discovery and learning experience. So not really on lack of vision, but lack of learning, I would say. So the team failed because they didn't realize that building is really all about building software, building products, building projects. it's all about experimenting. It's all about learning, because we simply don't know what we need. We are uncovering our needs. We are adjusting to the needs of the clients. We are listening to the feedback and then changing everything. But instead of revalidating the model and finding something Eric Evans calls conceptual contours, which is a kind of model, which is a moment of modeling when a model is not, the development of the model is not so hectic. It's getting stabilized and finding the state where it can actually solve all of our issues, all of our problems, all of business requirements. So instead of revalidating the model and finding these conceptual contours, they decided to build prototypes all the time. And by prototypes, I mean building everything, including every layer. So domain layer, application layer, infrastructure layer, all that kind of stuff, right? So like building a new little product every time. So basically prototype seems like a very good idea, right? And it would be a good idea if we had all the money in the world and all the time in the world, right? So unfortunately, it's extremely costly. And because it's extremely costly and it requires a lot of time, the learning rate is way too slow. All of the things like infrastructure, services, communication between other participants, other clients, slows the team down dramatically. So maybe another question: why do we write software? What's your opinion on this? Okay. Yeah, exactly. Exactly. To solve a problem, to provide value to the customer, provide value to the client. That's exactly about building a product. That's why we are building products. We are building software products, right? So it applies the same to the building software, right? To solve problems. In most cases, specifically business problems. So, oh, is video working?
Yeah, it's
Awesome.
working now. Yeah.
Hi everyone. It's nice to be here. Okay, so let's try to summarize. In general, why projects fail? Not this specific project, but why projects in general fail. I've pointed out three main reasons. One of them is something we call CV-driven development. And I am also a culprit here, right? I also done this kind of stuff. I think that most developers actually try doing CV-driven development. If you don't know the term, it's all about learning stuff. So you're basically getting into the project to learn something, to try some new technology, try some new stack, some new language, some new framework, so you can write it, add it to your CV, right? And increase your chance of getting a good hire. So yeah, projects fail because of CV-driven development, and because actual developers don't see the bigger picture here and don't know why they are building it. The second reason is that sometimes projects fail because of technical skills. And if there is a lack of technical skills, projects fail dramatically. It can go all wrong. So, but one thing about it is that that's usually not the main reason, right? If it's the main reason behind it, then yeah, everything goes wrong. After all, we are building software, right? We need some hard technical skills, hard learned programming skills, architectural skills, etc., etc. But usually not the main reason. So if I was about to point the most common reason behind failing is that, again, we are adapting too slow, right? We are not learning fast enough. We are not adapting fast enough to the changes. So we are not changing our model rapidly enough to introduce all of these new domain findings and requirements we gained during the development of our software. In my opinion, that's the main reason behind it. So what can we do about it? Well, the answer is very naive. We need to learn faster. Okay, but what's the best way to learn? Okay. Can you try to answer this? What's the best way in your opinion? Experiment, practicing, yeah, learning by doing, right? We can't actually learn by theories, by learning through some courses, learning through reading books. It's not possible. Doing an reflecting on failures, yeah, that's also a very good answer, Laura. Trying to explaining, yeah. So these are all very, very important things we can do to learn faster. So that's also, in my opinion, the thing about it. So by practice, by experimenting, yeah, exactly as you said, because after all about practical science and engineering is based on experiments, right? We are doing practical stuff after all, right? So it seems the same rules should apply. We are also experimenting, just as chemists, just as physicians, just as engineers, right? We are engineers, but software engineers. So it seems very similar that we also need to gain some knowledge, try some stuff out. And by experiment, I not mean only learning technical stuff. So like, okay, let me try this new shiny framework. No, I don't mean I don't mean that by experiment. By experiment, I mean learning about your product, learning about your needs, learning about the business, learning about the domain. So how can we run, or can we even run experiments in code, right? On code. As I said already, prototypes are not the best and cheapest way of learning, right? So instead of running prototypes, we can run experiments directly on the domain model. And by running experiments directly on the domain model, I mean getting to the code and adjusting the model so we can try to incorporate new findings, new changes to the domain and see if it works. So why we are experimenting on domain? Because it's cheap, and at the same time, it's the heart of the software. True, we need to have some architecture. We need to have some design where a domain model is inside it, is in the center of the software. Otherwise, we might place schematic logic in application layers, in infrastructure layers, in messaging layer, middleware, etc., etc., right? So, but if we keep the domain model directly in the center of everything, so all the use cases, all the infrastructure stuff are just layers on top of the core domain. Then by experimenting directly on the domain model, directly on the core domain model, to be specific, is actually experimenting on the project, right? But it's cheap. I mean, usually model are just, in Java are just pojas or some functions in other languages, or maybe even some structures. But usually these are the pieces of code where you don't need to write any glue code, where you don't need to integrate with any other services. So we can focus that just on the process, just on the domain requirements, just on the behavior, and see if you are getting into the right conceptual contours. Okay, so how do we run these domain experiments? Basically, I found that there are two types of domain experiments. Something I call initial experiments. It's what we do when you're starting a completely new project or building a completely new feature. So you don't have anything except of requirements or of some description. Then you're running initial experiments. And the characteristic behind it is that it's extremely chaotic, but at the same time, learning is exponential. So because everything changes so rapidly during the initial experiments, you can't really afford to start building prototypes, right? I mean, yeah, that's what project teams do, right? Teams try to build experiments based on some initial model they developed without giving a validation to it, without checking if it's working correctly. If we are starting to get not in the conceptual contours, because that requires a lot of iterations and it happens usually later, but if we are at least trying to get to the right direction, right? So it's extremely chaotic, impossible to actually build prototypes to have fast learning rate. But if we focus on the domain, then even if it's very, very chaotic, the learning, on the other hand, is exponential. It's like a burst of learning experience. We are learning so much new concepts that they can even overwhelm us at the beginning. But it's kind of like getting exposed to the stream of the domain knowledge, right? If we are doing it right. We will talk about how to do it right. Then there is another type of a domain experiment, and which I call life experiment. And it happens when we need to introduce changes, challenging some upfront decisions. So usually working on the brownfield projects. Okay, so let's start with initial experiments. Initial experiments usually happen when you don't have anything. You just have a green field, and that's all. And that's all about it. Okay, so how to run these initial experiments, right? So first of all, I usually do a session of example mapping. Example mapping allows us to express some very concrete examples. And these very concrete examples can be expressed, for instance, on tools such as Miro or any other sticky note applications or any whiteboard application where you just write stuff. It really doesn't matter. Important thing is that you chop the pieces of the processes explored, for instance, in big picture event storming session into some processes and then into examples. And when you have concrete examples, everything starts getting much easier than just starting to hack stuff without understanding concretes. So the second step is adjusting the emerging model according to the examples. And important thing here is the word emerging, because we don't have model yet. Actually, we have just a problem space. We have just a domain space without any solution space yet, without any model covering the needs of the business. So that's why in the initial experiments, your model is emerging out of examples. I usually do test-driven development to support this, or BDD if you prefer the naming. I don't really care about it. Okay. Then you are verifying the model you've just created, or which is just being created. And for this step, code storming might be a good name. I don't know if there is such a thing somewhere out there, if someone used the term, but that's how I sometimes think about it. It's like a session similar to the big picture event storming, but based on code, right? So it's also very chaotic, but we are experimenting on the concrete code. So to verify the model, we first need to challenge the model. In other words, try to break it. So if we know the examples, if we know what we need to implement, if we have examples expressed as tests, for example, then we might try to ask ourselves, okay, so we see there is such requirement and the other requirement, and we start thinking about these requirements, and we are starting to thinking if our current model supports all of these requirements. Can we express all of the behaviors? Can we express all of the requirements, and how the model actually behaves in such terms? And not only about supporting it in terms of features, but it's also a good moment to verify if technical stuff like performance is good enough. For example, if you created a huge aggregate, at this point you might start thinking, okay, this huge aggregate satisfies all the requirements because it's huge. Yeah, you can create one aggregate per application and everything would work, right? But the performance would be dramatic, right? Impossible to implement it correctly. So that's also the moment when we need to consider such things. Challenge the model. See if it supports all of our needs. See if there are some performance issues, obvious performance issues, and try to break it. Then ask others to challenge the model, just like you did in the A. So in the previous point, and include as many people as you can. So the first step, the challenge the model step, usually do alone. Then after your local code storming session right in your head, you ask others, you invite others to break the model, right? So at this point, you can try some kind of mob programming. I'm usually not a big fan of mob programming, not even pair programming, but there are moments when it's working. And the B is a moment when you can actually try to do some mob programming. See if it's working or not. Ask others if it breaks, if they can break your model. Okay. And after that, you ask everyone in your team for review. You don't necessarily need to use some isolated pull request, some special branch for it, because initial experiments are extremely chaotic, as I said, right? So it might be very hard to work on it without some kind of unstable trunk, since you are trying to introduce something, check if it's working, okay, introduce. There would be too much hassle around some special branches just for the experiment. It's too early for that. Plus, the most important thing about verifying the model is that you're sharing the tribal knowledge. Thanks to that, everyone can see where your changes are gravitating. And I mentioned everyone, so everyone in the team can at least take a look. They don't need to get into the details, but they at least need to know what's changing in the core domain. And it's important because we are not changing on stuff like, I don't know, changing adapters from REST API to GraphQL or using to use the protobufs, not that kind of stuff. It's not on the boundary of your context. It's right inside the center of the context. And since it's right inside the center of the context, it's usually extremely important to let anyone understand what's changing inside the heart of the software, right? quoting the name of the Eric Evans book. Okay. So that was about the initial experiment. Now, how to run live experiments. Experiments usually working on brownfield on a developed project of some maturity. So we start the same. We do example mapping, but then we create an isolated branch. And a good name for it is something like experiment 0, some number, and then a name of the feature. The reason why we are creating isolated branch is that very often at this moment of the development in the brownfield project, you can't easily incorporate changes based on your experiments. Okay, I explain a bit more about it later. So then you start hacking the existing model, right? So you take the existing model and try to modify the existing code if you can do that, if it's feasible to do this, right? And if modifying the existing code requires too much work because of all the dependencies, because code is tangled, because there is no clean architecture, because there are no tests, etc., etc. So because all of the application infrastructure layers, etc., then you create a new code based on the existing one, completely new code. I mean, a new code, but you can use copy paste here, right? You are not trying to modify. You are based on the knowledge you accumulated so far in the ongoing project. You take all the decisions, all the domain decisions, all the model, and copy paste them and try to adjust them just on your experimenting branch. And then you start a draft pull request. You can use, if you don't follow any kind of pull requests, if you don't need to do that, then you can try maybe use some feature, not feature branches, but feature toggles, something like that. Anyway, it's important that you isolate this. You isolate your experiment. Then you verify the new model. And it's exactly the same as it's in initial experience. You challenge the model and ask everyone for a review. Again, it's all about sharing the tribal knowledge about the changes you're introducing. So then if your experiment is accepted by everyone included in the pull request, then you can try to merge it. If you modify the existing code and everything is working, or you polish your new code, you change it so it can be merged with the main branch later. But there are moments, as I said, when experiment changed so much in the domain model that you simply can't merge it. I mean, yeah, you could merge it, but then your experiment would live like weeks, probably. Yeah, it's not a very good idea. It's usually should end in one day. Experiments should end rapidly, should start rapidly, and should end rapidly. So in case your experiment changed the domain model so much according to the new requirements, because for instance, you found out that there is some intrinsic complex domain logic inside your system, and you found out that so far the team has created typical CRUD code, create, read, update, delete, everything just writing and reading from the database with some logic interleaved with transaction scripts or some intelligent smart pipes in your messaging system. Then basically you can't easily say, okay, I found something great. I understood something according to the requirements, according to talking with domain experts, and I would like to incorporate this. But you can't, right? You can't do that because it changes too much. So in such case, you don't merge the branch. You don't wait to polish your code. Instead, you use it to gain a deeper knowledge based on your requirements. Then again, since you asked everyone or as much developers as you can from your team to have a look into your changes, they should at least understand what you have found about the domain, what you think should change in the model. So in such case, this branch simply dies. I mean, dies in terms of it's never merged. It can be left and should be left, in fact, in a history for a while, so everyone can have a reference to the model. But what they do next is they can start working on new feature. Depending on your model, you can start again having some small feature branch or follow the unstable trunk approach. It doesn't really, it's not really important. Important is that based on the knowledge, not only now your knowledge, but knowledge verified with domain experts, thanks to the examples, knowledge gained because of the verification of your model from the other developers, and based on your insight, you are actually having quite a lot of knowledge. You can try to incorporate that knowledge to your project. So you start doing then small changes. You can incorporate everything, but at least you understand where you should go. What's the correct direction? You see the point of the development. You know where you go. You know what's your goal. That's extremely important. So, as I said, live experiments can help you only if feedback loop is extremely short, right? So these pull requests or isolated experiments shouldn't last longer than 1 day. Otherwise, they stay behind the main trunk and naturally start to differ from the development. So it's an experiment. Don't work too long on it. At most 1 day, and then ask the others and include as many people as you can, right? Preferably not only developers, if it's possible. Okay. But it happens that your team is unwilling to learn. It happens that your team is unwilling to challenge the previous decisions because of some kind of pride, because they created awesome system. Yeah. They create a system which actually sells, earns money to the business holders. So it must be awesome, right? So if your team thinks that their design is the best one ever crafted, and because of this, they don't really feel they need to change anything, then you're basically doomed. In case of experiments, at least, right? I mean, then don't even try, don't even bother with all I've just said. Do the stuff you usually do. Focus on something you're currently working. It might happen that to some point it might work, right? So if it worked up to the point where project started selling, then yeah, you can go with the maintenance. Then you can create prototype after prototype, change after a change, rewrite after rewrite. And if company is earning a lot of money, it might work. It would take much more time and waste much more money. But sometimes it's easier to spend money and ask developers to work than to challenge the upfront decisions, especially if we are working in a team where there is an architect which is absolutely sure about her knowledge and expertise, and is holding everything and is unwilling to change anything, right? So then simply experiments wouldn't work. Experiments in such case would only waste your time, in fact. Plus, they might lead to a lot of frustrations because you are trying to change something. You are having great findings. You are feeling that you are doing something meaningful, and you want to incorporate this into code, into the model, change the code so it works according to all of the needs of your clients. But then if no one is unwilling to even take a look at your experiment, they might say, okay, try it, but they're unwilling to cooperate with you. Then, yeah, there would be a lot of frustrations, right? Okay, so getting to the end of the life experiments. If experiment is accepted, then keep track of your model changes. For that, you can use architecture decision records, where you create small text files describing the context, the decision, and the consequences of a decision you've made, but applied in such case directly to the model. You can use architecture decision records for any kind of decisions, architectural design, technical stuff, infrastructural stuff. It all works. But here, I mean architecture decision records in terms of model changes. So maybe the name architecture is not the best word. Maybe it should be named the design decision records. But it's all about the same thing, right? You write small text note, no longer than 1 page. Usually there are just few sentences inside it. There are tools to generate them, tools to index them, tools to supersede them, like ADR tool, for instance, ADR tool, command line interface app. And then you add the ADR directly to your repository, which you introduce changes to. And then the ADR helps your team, especially new members, to understand the full context. And it might be especially useful when you are trying to challenge previous decisions, right? Because you can then see if you're finding the model, because all the changes you are making through the experiments are also prone to making some bad decisions, right? You can make bad decisions based on the experiment and can get into production. But if you get through the experiment, then at least you have the ADR, and then you can try to justify what at this moment the team decided to go with this design. So it's especially useful when you're challenging these previous decisions, because it might happen that some developer had a very, very good reason to design them all this very specific way, right? Okay, so that was about life experiments. Now, how do we combine it with the example mapping, and why example mapping? Why we should use example mapping? So, as we said, there is no better way to learn by examples, right? Also, examples help to clarify all the requirements, so you can have a very meaningful examples, and you can find inconsistencies between these examples. Then examples we can also understand. By examples, we can also understand what are the real business needs. And now, when you combine example mapping with test-driven development, then magic happens. I even go to the point where I actually do example mapping using test-driven development without some sticky notes. I mean, people can run example mapping using a lot of sticky notes for quite a long time. Usually I prefer to have a very, very simple scenarios expressed in, for instance, expressed on whiteboard through Miro or any other tools through stickies, and then go directly to the code, because only code is the only source of truth. Only code tells you the truth. Only code can show you inconsistencies. You can write everything on paper, but you can't write everything in code, right? So it works. So that's why I go directly to the code, and usually have a lot of findings working straight on the code. Okay, so I've explained what I understand by domain experiment. What I understand it in my terms, and what we should do, how we should proceed with it, what are the gains. And I think it's a good time to see it in action, to see some demos. But before we get there, do you have any questions? Yeah, ADR tool. Yeah, exactly the same thing.
Mike, normally people are allowed to unmute themselves, so don't hesitate to unmute if you have a direct question to Mike, or post it in the chat, but don't hesitate. Or give feedback. Or... Okay, let's keep it for VN maybe.
Okay. Yeah, there's one question. May I ask if there will be recording? Yeah, there will be recording. Okay, so yeah, let's get to the action. This is the link to the repository. I don't know if I can simply copy paste. Yeah, I can copy paste it. So I can send it here. Okay. And before we get directly to the code, let's have a short overview of the project I mentioned about at the beginning. So basically, the motivation behind crowdsourcing is that active investing requires a lot of time. Investors don't have that much time because they usually are more focused on earning money, right? Instead of picking up some projects manually, they would like to invest into some group of assets. So our value proposition at crowdsourcing is to allow investors. There is bold word here, as you can see, because it's kind of one of the main definitions here. So crowdsourcing allows investors to invest into any kind of asset. Borrowers then repay loans. Crowdsourcing is a fundraising platform which allows investors to allocate their money passively into groups of assets using automated strategies. So that's the main value proposition behind it. And I created 4 main requirements, which simulate very initial overview, like you are starting a very first version of a startup. So I've combined just few requirements, very initial requirements we should implement. So any borrower can start the fundraising to finance her project. Investors can invest into assets. Investors receive returns based on the asset they invested in, and borrowers receive funds to finance their projects based on the schedule. Okay, so these are 4 main requirements. And during the demo, I'll show how to go from the beginning and incorporate mainly initial experiments into our model. And then I'm going to show how we can go with live experiments where we have some code base ready, and then we need to change something which completely changes the way we perceive the model. So let's start with a Miro board. So If we are starting on a completely new project or trying to understand the existing one, usually it's worth to at least run very simple big picture event storming session here. Okay, so maybe let's navigate through frames. That would be easier. Okay, and there are two versions of the big picture. I'm not going to do it step by step, as I don't want to waste too much of your time. But I'm going to show you two versions of the big picture. It's very simple, right? So we can comprehend it during the demo. But when team started adding stickies, some main events appeared, like project funded. You see there is even a duplicate here. So then investment made, project defaulted, yeah, and then we can ask what means the project is defaulted. Funds received, deposit made, funds withdrawn, payment not received on time, schedule accepted, project repaid, interest paid, project cancelled, project started, borrower registered, investor registered. That's how it might look at the beginning when someone just places everything. Then in the next step of the big picture, we are usually trying to categorize these events into some kind of processes. So we try to order the events, usually based on time order. And then we can try to start finding some processes. Usually, big picture is actually event storming setting is actually about main three stages. It's big picture, then process level event storming, which is not shown here. Process level is a bit more detailed than you can see it here. Also including some external systems, main users, main roles, etc., and some maybe some hotspots. But for the simplicity, let's just show two iterations of big picture, in which we found out that there are two main processes. The first process here is about the fundraising. So the fundraising looks like this. The borrower registered, then the schedule is accepted, then the project is started of the schedule is accepted, then the project can be either canceled or funds can be received to the project. And after receiving enough funds, project can be funded. Project could be also defaulted here, but since event storming is all about interactions, there could be holes in the processes, and that's natural. That's why we are going to use example mapping to concretize everything. So here in the investing process, it works from the other side, from the side of the investor. So from the perspective of the investor. So investor is registered, then the deposit is made to the account. Again, not everything is called properly during the event storming because people are just adding stickies, right? That's why I decided to leave it like that, to simulate a bit of real session. Then the investment is made and project is funded, and then interest is paid or payment not received on time. And if payment is not received on time, then the project can be defaulted. If interest is paid fully, then project can be finally repaid, and investor can withdraw the funds. So funds can be withdrawn by the investor in the investing process. So that are very initial findings. So usually we need to go for something similar to this. I mean, we start with something like this document. Yeah, naturally it's is a bit bigger, right? And includes more things. Just watch out if you're not getting a lot of paper on your hands. So in good teams, usually there should be a small vision document, and based on this small vision document, as Eric Evans calls it, then we might get into knowledge crunching through event storming session, starting from the big picture. And this allows us to find very main processes which we are going to implement. So after big picture, there is process level event storming, which I'm going to omit here. And after this, there is a design level event storming session. And in design level event storming session, you are actually trying to find a solution to your project. And by finding the solution to your project, we usually mean, again, adding new stickers. I mean, but this time talking about aggregates, commands, which aggregate processes which command, produces which commands, which process consumes which event, which policy consumes which event, and invokes which commands, what's the interaction with the external systems, with the stakeholders, with users, etc., etc. So getting into the solution space instead of problem space, as we've just created a draft of it here. But there is one problem with the design level event storming session, which I usually don't like, mainly because we are still working on stickies, right? So since we are still working on stickies, as I said, you can write everything there. So if there is some contradictions in your stickies, if you don't find it out, then they can stay like that and can introduce a lot of problems later during development or even on production. So instead of running design level event storming session, which can be very useful if followed correctly, but instead of doing this, my preference is to go directly to something to the example mapping. So I go to the example mapping and try to map the most important scenarios into examples. And it looks usually like that we are taking something based out of the process we found out in the big picture event storming session. For instance, a story behind starting a project, a story behind canceling a project, receiving funds, funding project, making deposit, withdrawing funds, paying interest, repaying project, defaulting project. And people can, again, could walk in parallel to find out this main use cases, this main stories here. So some of them are not always mapped, just like in this example, right? Since we can usually focus on one thing at the moment. So we are starting, for instance, we are focusing on starting a project, and then we try to write these examples. And the format of classic example mapping looks like this: that there is a story. Then on blue notes, there are rules. And on green notes, there are concrete examples according to these rules. And often you start with a rule, classically, but personally, I prefer to go a bit different way. I mean, I start, when I think about starting a project, I don't go with the rules yet. I don't try to write these rules. Instead, I focus just on the examples. So I try to create examples of some behaviors in starting a project use case. And then we have things like adult borrower starts a project, borrower without criminal record starts a project. Then we can fund projects which cost less than $10,000 or need to be verified manually when greater or equal to $10,000. Then the example about schedule is accepted and schedule is not accepted. So usually I go just with the green examples, And then I try to categorize them into some rules. But so we can say, for example, that only verified borrowers are allowed to start a project, or project must be verified first, right? But if you omit completely these rules, the example mapping session can be also very fruitful. So what I usually do is that I don't go through all of these use cases, but after laying out these main use cases we want to focus on, I begin with the first one, which looks the most important one. You can ask other participants of this session to give their votes and vote which one should be prioritized. You can use t-shirt mapping or anything you want to. And then you start creating concrete examples on written on stickies. And after having some, I can't say how much, it depends, but not too much. After having some examples, what I do is that I go directly to the code. So after focusing just on sovereign projects here, what the team should do is to go to the code to show these examples. And I've already prepared some comments here. We started with init project, and just to show it, show to you, there is nothing basically in main in Java except of just the main application class. There are no tests. There is just documentation. So basically, there's nothing about it yet. So then you can see that there is a starting a project step 0 commit. You can see it's named exactly just like the use case. So we start with this one. I'll check it out. Okay. And I'm going to show you step by step what changes would be introduced, would be made to the code to go through these examples. I would not do live coding from scratch, as that might require too much of time, and I might lose your attention. But I think that going step by step would be good enough. So the first thing here is that I start with a test. And I start with a test, which I named something with a test class, which I named something like examples from my row. And here I'm giving you a link to the document, to the PDF document included in the project after the example mapping session. Example mapping sessions are versioned. So example mapping version 0 here. And then you can see that inside it, I categorize these use cases as nested classes, again named starting a project. Yeah, starting a project, exactly the same, right? And here, since we don't know what we are actually building, remember we are showing initial experiments at this moment, right? So since we are showing an initial experiments, we don't know anything yet. We just have this board, we just have these requirements, and we write first lines of code for the project. So I don't really focus on the name, so I just call it example mapping test. The test here is just to allow JUnit to detect, Maven plugins to detect it as tests, and that's all. And here in start a project, you can see that I am having first example. Again, using the description, that's a multi-line string in Java. Oh, that's not important. Important is how this concrete example looks like. So given adult borrower, when borrower wants to start a project, then project is started successfully. And it's this one. it's this one example here translate into code. So adult borrower starts a project, and here we give an adult borrower one borrower needs to start a project, then project is started successfully, right? And except of writing this requirement, these examples here as plain text, I am also trying to use domain some domain namings in the code. So you can see, for example, that we are having some meaningful factory methods here, like any adult borrower, and then when borrower wants to start a project, yeah, it's mapped from the description, and then we here since our domain logic produced some events, then we check if the event project starter has occurred in the event. So it's expressed here. It could be made a bit more readable, but you get the point here. It's our first move. The code is not perfect here yet. We have just started, okay? And inside the borrower wants to start a project, you see that here I wrap these things like that. So our code can be, our tests can be read can be read as examples. And also because since we are working on a very dynamic project, the exact method names, the exact parameters, the exact receivers of the commands would be changing all the time, since these are initial experiments. So that's another thing why I'm usually using the kind of DSL for these examples. So you can see that at this point, I am not really concerned about the naming, right? During the design level session, we usually are encouraged to find namings for the aggregates. I don't care about it yet. I don't care if it's factory, if it's aggregate, if it's domain service. It's not important for me at this stage. We are starting from nothing. So we are just building our language through tests. So here, borrower wants to start a project. It means simply that there is some kind of start project command handler, which has method start project by borrower, and that's all, right? The nice thing about all the descriptions I'm showing you here is that when I run this in Java in Jupyter, okay, you can see that the report is quite nice, right? So examples from my role, then starting the project, and then given an adult borrower when borrower wants to start a project and project starts successfully. And that's what you would see in the report, also in the generated XML report. So yeah, frankly, I would use Spock because Spock is even better. But the problem with Spock is that it has its issues when you are doing a heavy refactoring. It can give you then false negatives and false positives because some tests break after you are introducing too much refactoring on your types. And trust me, when you are doing experiments, initial experiments, you would be refactoring a lot. So yeah, that's that's the reason why I prefer a bit less readable Jupyter 5, compensated maybe a bit with some display name here, which can help you to read it. Then very nice Spock, because it usually, at least from my experience, can break when you're experimenting heavily on the model and types. So that would be the very first step which you would start with. Then let's go to the next step. Okay, to the next revision here. Okay, so let's take a look. We are again having starting a project, and we are having the example given adult borrower when borrower wants to start a project and project started successfully. Then we have another example, right? Again, still based on this example, but the other way. We had a positive scenario. Now it's time for a negative scenario, right? So given borrower who is 17 years old, when borrower wants to start a project, then project is not started. So we are having given borrower of age 17 years old, and this borrower wants to start the project, and then there are no events which occurred. So nothing happened. Okay, we could use some either with exception or simply throw in exception. It depends on our flavor. I decided to simply not produce event at this first iteration here. So yeah, maybe one important thing is that when I start writing such a test, I do it like that. Maybe I'll just show it. Given something, when do something, then expect some result. Okay, and I am using macro here, but it's not important. Important is that I don't start with code. I start with this example, and then I am having a word and I am having a ubiquitous language being constructed during writing this example. So given something, what should it look like? It would be something, right? I am not having something, so I would create something. Okay, it's created. Yeah. So we are having something. Then do something on something. Yeah, it doesn't make sense, right? But let's show it. You see, there is not. It's not initialized. Okay, so maybe we should build it. Okay, and then something do something. We again create a method based on the requirement, right? Do something. Okay, great. And then what we want is expect some results. So we need some results, right? Result. Yeah, we need a result. So create something, maybe record. Okay, and we are having a result here. But now something, do something method is not return anything. So what we do, again, make do something returned, right? And it returns a result. Okay, great. And after that, we might express it that assert that result is, for instance, not null. Yeah, it should be a bit more readable, a bit more domain oriented, but you get the point. So that's how I proceed from the examples when I try to do example mapping. When I try to do example mapping using test-driven development, you see it's all combined, right? I start from the description. I would start only with the description if I found out some initial example here. And then my code emerges. That's why I said that in initial experiments, the code emerges from the examples as you write them, right? And you are immediately consuming it, immediately creating it. So you are getting a lot of benefits like building a ubiquitous language, having a domain-oriented model, and you can find some inconsistencies and errors in your thinking, and that's invaluable. It's just pure gold. Okay, so that's how the process look like. Now I'm going to reset this. Okay. 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 And let's go to the next step. That's step number 2. A still starting project scenario. Check out. Okay. Yeah. And we are getting something more. You see that our tests are getting more and more concrete. So the first one is the same about adult test, but the two-young test is now expressed as a parameterized test, which accepts some years like 17, 16, 8. So given borrower who is younger than 18 years old, when borrower wants to start a project, then project is not started. Yeah, and I can write it. And again, you see, we have a very nice reporting, by the way, right? And this reporting is actually speaking the domain language, right? So given borrower who is younger, given borrower is 17, 16, 8, 4, 2, 1, then a project is not started for all of them, right? So that would be the next iteration of the same example, still working on the same example, getting more and more concrete, and changing the model. As you can see here, since we are starting on something very, very naive, I even tried to do something like that, right? So when I'm having a factor method borrower of age, I simply type the years, right? I tried to simulate the situation when you are treating the example literally. So when you're having an example like given a borrower who is younger than 18 years old, I simulated the behavior where you actually typed years exactly in the age value object into the borrower, which, well, it's not the best idea, right? We wouldn't want to update the age of the borrower each time she gets she gets older, right? So naturally, it wouldn't work. But I included this as a step to show you how we can refine our model, right? Again, if you were building a system, a true system, naturally you wouldn't even consider this. But I decided to have such a naive example to show you we can apply the same approach of iterations of refining the model according to the examples, even if there are a bit more complex requirements, complex examples. And in such case, you use exactly the same way you're iterating, right? So you can do something which you don't understand. For instance, you might not understand some principles of investing. So you might write something as stupid as this, but expressed in the investing domain. But you would find it out later during the iterations if you are talking about it with the rest of the team and preferably domain experts. So let's go to the step 3. Okay. Let's get to the step 3. Check out the next revision here. And there was a very small change, just the concept of the age, to change the concept of the age, right? So if we had, you see, the test looks exactly the same because we are using factory methods, and as I mentioned previously, that's what protects you from changing all the constructors or the invocation of constructors or invocation of methods if you're operating through the ACL of the DSL of our test DSL. So we still have borrower of age factor method here, but here in borrower of age, we are not actually telling that a borrower is X years old, but instead we give a birthday, right? According to our finding. And that's another iteration. All tests would still pass. Okay, so then let's go to the step 4. As you can see, it's named starting a project. Step 4, the first breakthrough. So let's get here. Okay, great. So the first breakthrough. Oh yeah, you see, we are getting some more things here. Okay. So this is our mapping. These are our 2 scenarios now: starting a project and new borrower registers. Oh yeah, do we have new borrower registers here? No, it seems we don't. We don't have new borrower register because I'm showing you how it would work in going through iterations from nothing. We might not think about everything from the start, right? So instead, examples expressed as tests might lead us to some design, to some findings, to some direction, which can actually give new findings to the examples, to the requirements. So what was our new finding here? You see the first test here in starting a project is changed a bit now, because we realized, we found out during writing these examples that why do we want to verify borrowers if they're adults or not when starting a project? We don't want to have borrower in our system who is not adult. That's the first breakthrough. Very small breakthrough, because we've just started a project, but we are already finding stuff. So we found out that we don't need to validate it when starting a project. We need to validate it during the registration of a borrower. We don't want to have borrowers who are not adult in our system at all. So that's why the first example here is re-expressed. Given borrower, any borrower basically, not young or old. When borrower wants to start a project, then project is started successfully. That's okay. When we are having borrower, then at this moment we can simply start any project by any borrower. Remember, it's not the full story. We are discovering the story. We are discovering examples. So we are iterating over the experiments here. So that's about it. And now we are having a new scenario, new borrower registers. And here we are having a rule. Only adult borrowers can register their accounts. And here I'm having a parameterized test that checks if user can be registered. That's the birth date. That's the current date in the system. So when having this, we can see that only adult borrowers can register their accounts. Given birth date 204/06/10 and current date 2/22, then this borrower can register her account, etc., etc., etc. Right? Okay. Now, borrowers younger, new example, than 18 years old cannot register their accounts, right? So we again showing that these users cannot register the account as borrowers. Okay, so that's the first, a very small finding. But I keep it intentionally simple, so you can see the process, how we are going through these steps. And then what's important is that actually example mapping expressed as tests in test-driven development can give us new findings on the example mapping. So that's how new iteration of example mapping looks like. I decided to keep all the iterations so you can go through them. All of these boards are included here in the project, so you can go through them in example mapping directory. On the master branch, there is the most current one, and you can see that example mapping version 1 changed that we don't want to consider adult borrowers certain projects, so we can simply say, okay, we don't have such example because we found out there is a new use case, new borrower registers, and now we express it like at least 18 years old, less than 18 years old, younger than 18 years old, older or equal to 18 years old, right? So that's our new finding, getting straight from the code, because we found out some new findings. Why should we even keep borrowers which are not adult, right? Okay. Next step. Step 5, add application and infrastructure layers. I decided to show it here, even if it's not related directly to the domain experiments, but I decided to show you how we can wrap up everything and include all the infrastructure and application layers so far. So it usually wouldn't happen so early as I am showing it now. It would happen after some time, but about few days, we should at least have a structure, covering our business needs. Because sometimes it might happen that technical stuff might limit our decisions on the domain model, especially if we are working on legacy systems, or we need to integrate with some not clean enough legacy systems. So it's always good idea to have a shippable product with everything you need in terms of, I don't know, single sprint, a few days. I don't really care about sprints or I mean, as fast as you can, so you can actually run it here. So how you would structure is that, for instance, you would place it in something I call the managing project, which includes the following packages: adapters, domain, infrastructure, and use cases. And it's a self-contained module, includes everything. I am basically following hexagonal architecture, also known as ports and adapters architecture here. Everything is expressed through use cases. There is start project. A start project simply invokes a command on domain object, which is loaded through borrower repository and returns things like borrower, and there is a start project command handler. So basically what we do here is that when we start a project, we load the borrower, and if borrower is present, we start project command handler method start project by this borrower. And that in the infrastructure layer, we might have stuff like Spring configuration, registering all the beans, or any other configuration according to your needs, to your dependency injection, infrastructural stuff, database stuff, etc., etc., etc. And in the adapters, you are basically having primary adapters and secondary adapters for managing a project. And primary adapter is start project command line interface, which is a consumer of start project use case and adapts calls from application arguments passed in command line interface to start the project. Then we are also having a secondary implementation of borrower repository. Extremely simple, just keeping it in memory. It's even a fake repository, just to show you that how we could structure it. So and then if our model is getting right, we should be able to postpone all important infrastructural decisions. I mean, if we experimented good enough, found some initial model which starts to work, it would be changed many times, but starts to work, then it shouldn't be a hassle to create all the layers around the core domain. So that's how it might look like. You don't need to go primary ports and adapters architecture. You don't even need to go with clean architecture if you feel you don't need. Important is that you need to focus on the domain first, right? Domain should be in core, and that's basically all about it. Okay. So now I would like to show you. Fast forward into the future, as it's called here, funding a project, a new process here, which tries to actually show some approach to life experiments. As you can see, there is a new branch. I called it exactly as I mentioned previously in the presentation. So experiment number 0. Experiments can be linked to issues if you want to. It can be linked in the name. It can be linked in the description of the comment. It's up to you. But experiment 0, invest into group of assets. Okay, and here I would try to simulate the situation in which we already have some working code, but we have a new domain finding, something completely new. So here you can see we are already having some code. We are having the managing project code. We are also having the funding project code. You can see that here we are this one, yeah. That's our regular requirement. Investing into projects example mapping, and investor can invest into any project. It's simpler, not so detailed as I've shown previously, to show that how some example behavior, some example requirement might look like. So we have an investor account. I'm not using factor methods here. I just want you to show that there is some existing code. So there's an investor account, and investor account has method invest into, and then you say, okay, you invest some money into some project here. So it comes out directly here. Oh, okay. I'm not having an example mapping actually board for that because I moved fast forward to the existing project. Okay, no matter. So in this version, investor can invest into concrete project. Yeah, it's named project. So investors can invest into them. But at some point, we have a feeling that it doesn't make sense. If you go back to the initial requirements, you can see that investors can invest into assets. Okay, assets meaning probably projects. So there is a naming which can be bad. But what's important is that it not necessarily, this requirement not necessarily goes in a line with value proposition. So you can see that based on the requirements, we created just the platform which allows investing into concrete projects. But in fact, in value proposition, we see that crowdsourcery is a fundraising platform which allows investors to allocate their money passively into groups of assets using automated strategies, right? Does it look to you like an automated strategy? Not really, right? And this is also a finding which might be revealed later during development. We might not even have it in the vision document, and we might find it later that actually, yeah, we started with simple crowdfunding platform which allows investing into any project, just like Kickstarter or something like that. But after receiving initial feedbacks from based on our MVP from our users, we see that there is a huge opportunity to support a platform for investing into crowdfunding platforms to support real estate market. And then you simply define, you invest into some group of assets to diversify your portfolio to minimize the loss of, minimize the risk of losing money. And that's exactly what we also had here initially. Portfolio diversification is essential to secure your returns. If you invest everything into the same asset, you risk all of your capital. How can we diversify our investment portfolio? Enter the crowdsourcery. So we want to allow changing this behavior, either defined in the vision document and we simply forget about it or made some design mistakes, or something discovered much later based just on MVP. So imagine, yeah, that there's very little code, right? Almost no code yet, but imagine there is more code behind it. Imagine that we are having everything just to support investing projects. So we constructed data models. We chosen databases. We used libraries. We designed contracts, everything we created just to invest into any project. And at this moment, we can't simply change the main branch and say, okay, yeah, now you are investing into this, right? You can simply invest into that, and you cannot invest into concrete projects. Yeah, because one of the reasons we want to do that is to allow investing passively and to minimize the risk. Investors, we don't want to allow investors now to make bad decisions. I mean, for instance, invest in everything in one real estate project in some underdeveloped country, right? So instead of that, we are allowing investors to invest only through groups of asset strategies. Yeah, a very important finding, changing a lot of core domain. And if you change something in core domain, it's actually bubbling up. There is a ripple, the change ripple coming straight from the domain and going to all the layers, to the application layer, to the infrastructure layer, to the contracts, everything, right? If you're changing something in the core domain, even if you are having a very good system, if you're changing the core domain, you're actually changing the assumptions. You are changing the assumptions. You are changing the heart of the software, right? So it must have a great impact, a great ripple, which goes to everything, basically, right? So we can't simply change it like we had it in initial experiments. What we must do is to create an isolated experiment. We can use a branch for that, and just to verify what we need. And we can experiment on the domain model, see if it's working. Okay, see, yeah, you can invest, but you cannot invest if then you are having an optimization strategy for investing, etc., etc., etc. And after that, you have knowledge. You can't merge it back yet, but you have a lot of knowledge, and you have a great breakthrough, and you can provide possibly best products to your clients. So how it might look like. We are, I'm going to show you the branch. Okay. I'm not sure if, yeah, okay. We are on experiment 0, invest in the group of assets branch here. And now you see I've created a new package in funding project directly inside the domain here. And here in experiment, it's called experiment 0. Investors can now invest only in groups of assets instead of individual projects. So we are having a concrete example. Investor can invest into groups of assets according to the investment strategy to minimize the risk. We start with a code. If you fill in it, for instance, if you want to show some examples to the business stakeholders who don't want to read these tests, even if they're readable and can be understood without really understanding code, but assuming that you are having business stakeholders which are unwilling to understand it, then you can translate this into example mapping whiteboard using stickies, for example, and then ask your business stakeholders to verify if these findings are making, if these examples are satisfying the new findings. Yeah, that's what I want to say. So investor can now invest in the group of assets according to the investment strategy. Something new, a new finding directly from the code to minimize the risk, right? And you see that there is a change here. Here in one block, we are having an investor account, invest into some funds, some money here, 100 euros. To, yeah, that's not too much, right? Should be probably something like, yeah, something like that, maybe, yeah. But you get the point. 100 euros, invest into, and here we are having groups of assets specification, right? Not a project. Groups of asset specification. We are not investing into a project anymore. So groups of asset specifications has a DSL, which allows to express your requirements as an investor. For instance, groups of asset specification invest into kind of asset real estate, at least 10 euros, at most 25 euros. It means that in a given single asset, in a given single real estate asset, you are investing at least 10 euros and at most 25 euros. So our algorithm now knows that if you wanted to invest, for instance, 1 million euros, you want to have thousands of investments made. So it's to diversify the portfolio. Yeah. So in fact, a very important change, unmergeable yet. And we can start walking around the experiment here. You see that here in the funding project, in the domain, we are having new package, not only in tests, right? But here in code, we are having new package, which bubbled out new concepts like asset, funds investment experiment, groups of asset specification, investor account experiment, right? And you see that what I did is I took some classes, copy pasted them here, changed them here, and renamed them so there is no doubt. So it's no longer called investor account as we have here in the previous version. We are not simply having investor account, but we are having investor account experiment. To distinguish between them. And we can start working in isolation, in our own bubble. And I said that it's bubbled out, right? You see, Eric Evans once introduced a term called bubble context. If you write bubble context, Eric Evans, you can find it. It's not written directly in the book, but there is a separate publication about it. It's about how we can apply domain-driven design in legacy systems. So what Eric Evans says is that you are creating a new context, which is called bubble context, which is an isolated context, and you run create new model, new shiny model according to the requirements, which is kind of translated through ACL to the existing databases in existing system. So it takes data from the existing system, but tries to interpret them. And you are still working on a bubble context, and you're creating bubble context. And when ACL is no longer needed because everything is ported to the new bubble context, you can switch the ACL off. And it's something similar, right? We are not really introducing some technical stuff yet. We are just experimenting on the domain. But after a while, if we want to start introducing these things, this domain experiment can be invaluable to actually start creating true bubble context, including all the technical details, right? We know what we need. We just need to code it. We just need to change it. We just need to translate it. And it's much simpler. We have a great overview what we are working on. Okay. Later you can see there are some changes to change borrower registration, change starting a project process here, add missing example mappings here. It's not about funding a project. It's not about the experiment here. It's just the continuation of the master. So maybe I'll just show some changes here to finish at least one example. You see, we are having again new borrower registers, but now what's important is that we are having new example: person with criminal record cannot register an account, and it's taken here. So here, borrower without criminal record starts a project, right? So what we are having here, that would be the new findings based on the code. So we start again with example. And it looked like that we started writing person with criminal record cannot register her account. We started hacking the model, and ultimately it led to the discovery of a new concept here called the borrower registry. Again, just to clarify things, we are finished with the live experiment I described previously. We went back to the initial experiments of the main of the master branch to finish the scenario. And here you can see that there is a borrower registry, new concept, borrower registry, which allows us to register users. And there is concept like a registration form inside it, which includes everything. So borrower registry allows to register borrowers based on registration form, right? And everything comes out straight in examples. We started encoding person with criminal record cannot register your account, then iterated a few times and found out that that's how we want to name things. That's how we want to build it. So here you can see that person with criminal record, when we configure the criminal record, yeah, you see a new name, right? A new word in the domain, criminal record, explicitly modeled. Criminal record is a strategy telling us has criminal record, has this personal person identified by personal ID, has criminal record. And if this person has, it naturally translates to the external system. And because it translates to the external system, it's an entry to the external system. I decided to create a simple, not Mac, but a simple implementation here, right? A sub implementation, which always tells that there is a criminal record. So if there is a criminal record for this borrower, then we are not actually allowing users to register. Then it throws borrower registry exception happening here. So we started again, followed the initial experiments, starting with new examples, and new code, and found out some new requirements. As you can see, the previous version here had borrower without criminal record starts a project, and in the next version we actually moved it to the new use case here. Yeah, these changes are marked here. So yeah, it's removed from here, moved here, person with criminal record tries to register, and there is a new term we found out during building actually the code, right? Called borrower registry. That's our new definition. And then if we keep iterating, there is a change starting project process, remove unnecessary borrower from invest examples, etc. I would move forward a bit here. And we can see that there are some more changes regarding, again, starting a project here. In starting a project, you can see that given project proposal of 9,000 total value, when a borrower wants to start a project based on this proposal, then project is started successfully immediately. Yeah. So that's here. That's the second example. That's the third version of the example. Fourth version of the example mapping. That's the fourth version of the example mapping version 3. And here, again, it's not created up front because we couldn't find out all the details when working on it yet. But instead, it's created based on the concrete examples expressed as examples as tests in code. Yeah. So here you can see that the given project proposal of 9,000 total value dollars, when borrower wants to start a project, then project is started successfully immediately. Yeah, and events has occurred. You see, there is a small refactor here. We would be refactoring a lot in our domain model. So instead of telling instance of event which happened, we say, okay, has occurred any event of type. Project started here. And then we are having another example, given project proposal of 10,000 total value dollars, $10,000 total value. When borrower wants to start a project based on this proposal, you see, new name, proposal, project proposal, then project needs to be verified first. Yeah. So there are a few findings. You see, we are having new events found out during the example mapping in test-driven development called project requested accepted for verification. And there is a new concept called project proposal, right? And there is a new concept also called project proposal supervisor, which decides whether to accept or not. That's something which previously at the very first version was called start project command handler. Now we found out some new namings, and we found out that the right name for it, at least in this version, is project proposal supervisor. Someone or something, some process which decides either manually or automatically whether we can start a project or not. So yeah, there's start a project, and it's checking these requirements according to the examples we had. So if project proposal is at least $10,000, then whenever wants to start a project, then project needs to be verified first. So that's why when we, you see that we are still using exactly the same. We are still using exactly the same method. Yeah, I am just adding context by having fields here. So all the methods have access to the full context set up by each test. So we don't even need to pass arguments here. And now borrower wants to start a project. And now what we do is that assert that there is one event and that occurred any event of type, and here a new name, project request accepted for verification. So it needs to be manually verified by something, someone, something, some organization. It depends, right? It's yet to be uncovered. So you see, again, by going through the concrete examples in code, we had new findings which we can again incorporate into our whiteboard, for instance, for non-technical stakeholders. And now we see that there are a few new definitions. Project proposal supervisor. We can verify if these names are correct, because it usually happens that some developer having greater domain knowledge says, okay, yeah, it's called like that. But then we can verify through the whiteboard with business stakeholders that these names are correct or not. I also placed it here changes, you see, in the model. Yeah, why not? We can include everything, even pieces of code in our during our example mapping sessions and even storming sessions. So basically, we can include everything here, show some code, and show some changes. Yeah, I again marked everything that was changed. They're starting a project. It's okay when less than 10,000. And we found out that there is a new event. Actually, we can add a new event to the example mapping, and then go back to the process level event storming session in new version and add these missing events if you want to. But important is we found out new events, new minimum domain events, project started, and project proposal accepted for verification. Here, yeah, it seems it actually was included previously, right? I just added it here, but this one is definitely new. Project proposal accepted for verification, and you find it. And now there is a hotspot. How verification works, yeah, and then we can address it later, right? And this is our new finding about it. Yeah, so basically that's all about the demo. We're gonna have question and answer sessions probably after a while. We are getting to the close. I've shown you how we can run initial experiments and have new findings, and also shown you how we can run live experiments and incorporate changes, or at least have isolated branches to have some meaningful discoveries, domain discoveries. Okay, yeah. So it seems it's all. Probably was a bit long. So my name is Mike Wojtyna. It's nice to meet you. What I'm doing is that I am a Java developer, consultant, and trainer, helping teams to build better code, better architecture, and incorporate all the domain findings during their processes. If you are interested in areas such as domain experiments, test-driven development, clean architecture, domain-driven design, distributed systems, everything like that, then please do contact me. It's Mike at Wojtyna.pl mail. You can also find me on LinkedIn. Unfortunately, the Polish name, so it's you would probably pronounce it Michal here. That's why I decided to use Mike instead of Michał in Polish, because that's usually people call me Michal. So anyway, if you're interested in such terms, please do contact me. You can also visit my website, howtobe.pro, where I created an online training program teaching developers how to become professionals and incorporate all of the domain experiments, test-driven development, and all important universal skills for every professional software developer. Thank you very much.
Wow, thank you, Mike. Thank you. There was a lot of stuff in your presentation, in your demo as well. It was really interesting. And yeah, unfortunately, I think I've planned the meetup for 1 hour, so a lot of I've already left the meetup. But we still have 7 folks in the room. So please, guys, folks, don't hesitate to unmute. I think you should be able to do it if there is no problem with Zoom, and ask direct question.
Yeah, that would be the best to discuss it live.
Yeah, I think so. Yes. Don't be shy. Excellent. Thank you. Okay, I have one. I have several. I have always a lot of questions, but let's start by my first one. Have you already tried property-based testing on during domain experiments? Because I've done it a few times right now, and I've discovered plenty of stuff that I couldn't imagine on my domain model. So I was wondering if you have already tried it as well.
Yeah, I already tried and did it in few projects, and sometimes it worked out well. I mean, very important was that the team needs to be open, right? The team needs to be willing to change some things. So, for instance, when I tried to do something like that in one project, then I had a barrier of team actually not willing to learn, to discover things. I mean, they were extremely good developers, even good modelers, but the problem is that there was no culture of constant learning. So then it failed. Yeah, that's why I included a presentation title slide. That don't even try in such case. Yeah, it might still work somehow, but if you're having an open team, it might work extremely well, especially if you're starting a greenfield project and you're having something completely new. Then at least initial experiments is something which can give you a lot of insight into the model. So yeah, I tried it, frankly, with mixed results. Yeah, one time it worked really well, and we had great findings in the domain. It allowed to save a lot of money to the client. The other way, I simply decided, okay, I'm not going to insist on doing this. It wouldn't work in such case, right?
Okay, sure, I understand. Do you have any questions, all of us? Or in the chat, if you are not able to ask it directly? Nope. Okay, so maybe we can close for today. Thank you again.
Sorry for extending it.
No, but
I didn't even realize.
So
I didn't even realize it's almost 2 hours. So sorry for that.
No, but it's really cool because we have recorded it. So if you want to deep dive in, we have the repository. So with your explanation and the repository, it's really easy to try to reproduce it or try to do the steps by your own. So I think it was really interesting for people and for me as well, for sure. And the fact that you have a repository in which you explain the different steps going from your experiments in different steps, it's really interesting. Yeah, and it was really interesting during the presentation as well. So
just remember to take a look at Git log, so to see all the comments.
Yeah, sure. Yeah.
Okay.
So thank you again, Mike. I try to publish the video tomorrow. I will be in the train, so I will
Great.
check if I can do it tomorrow or the next day. Or the day
So
after it.
thank you very much, and thank you very much, everyone, for attending. It was a pleasure for me.
Shared pleasure. Thanks, Mike. Thanks,
Thank
folks,
you.
and
Bye.
see you next time. Bye.
See you. Bye.
Bye.